In this video, we delve into the fascinating world of space exploration and how artificial intelligence, AI, is revolutionizing the way we uncover the mysteries of the cosmos. Join us as we explore the vastness of the universe, from the origins of humanity to the possibility of extraterrestrial life. Discover how AI is being used to navigate spacecraft in space and determine orbits with incredible precision. With only 4% of the observable universe examined, we explore the potential of AI to unlock the secrets of the remaining 96%. We also discuss how AI can assist astronauts on their long and difficult journeys, performing tasks that would otherwise be impossible using only human capabilities. Space exploration has long piqued the interest of scientists and governments around the world because it holds the secret to the origins of humanity, as well as many other interesting aspects of the cosmos, such as the possibility of extraterrestrial life. At the end of the day, everything AI can do requires human intervention. Artificial intelligence is getting closer to providing new insights and is proving to be a boon to humanity in the exploration of interplanetary space with new machines, projects, and research with each new innovation. Especially in the facilities that can be obtained in navigating spacecraft in space and determining orbits with great mathematical precision. The visible universe consists of the regions of space that can be seen through telescopes. However, scientists and researchers believe that the cosmos may be bigger than anything we see. Scientists have only examined about 4% of the observable universe, which consists of planets, stars, galaxies, and other celestial phenomena that astronomers and scientists can see and understand. The remaining 96% have yet to be discovered. Artificial intelligence, AI, should assist astronauts on their arduous space journeys and help perform space tasks that would be impossible if only human capabilities were used. In space exploration, such as tracing unknown galaxies, stars, black holes, and analyzing cosmic phenomena, as well as communication, autonomous star navigation, tracking, and system control, artificial intelligence shows its enormous potential. Mission planning and operations, data collection, autonomous navigation and maneuvering, and spacecraft maintenance are all areas where artificial intelligence and machine learning are being used in current space exploration missions. Future missions will need to rely on the same technology. Imagine how easy it would be for scientists and researchers to achieve their goals, and how it would affect our lives if we combined the ideas of these two huge phrases, artificial intelligence and space exploration, keeping in mind recent breakthroughs in the field of machine learning and artificial intelligence. Let's combine these two concepts and see what's been done, what's happening, and what else can be done. To survive the 7 minutes of fear during the Endurance mission, the Entry, Descent and Landing (EDL) Flight Dynamics team had to rely heavily on mission planning, artificial intelligence, and complicated systems. Because of the complex planning required with these systems, mission scientists and engineers see scheduling as a domain where artificial intelligence approaches can be applied. Without AI, mission scheduling requires large teams to work long hours to meet mission requirements. By programming the spacecraft to determine on its own how to intelligently execute a command with a specific function based on past experiences and its environment, we can eliminate the requirement for these human resources. Real scheduling problems usually involve many constraints. Scheduling complexity is greatly increased by balancing conflicting constraints and making trade-offs. We can apply artificial intelligence to address critical constraints on science and engineering missions and optimize the timeline to meet all requirements. Mission Operations Management. For space missions, artificial intelligence is used in autonomous operations. Italian startup business AIKO has developed a software library called Mirage that is used to enable autonomous operations for space missions as part of the European Space Agency's (ESA) technology transfer program. The spacecraft can perform autonomous replanning, detect events, both internal and external, and respond accordingly using these procedures, ensuring mission objectives are met without delays caused by ground decision-making. Artificial intelligence and machine learning can also be used to assess operational risk analysis and assess safety-critical missions. These technologies allow risk mitigation systems to process vast amounts of data based on signs of normal operations as well as past performance where anomalies have occurred. We will not be able to confidently determine the risk level of phenomena without deep learning, so we will need professional supervision. Once the model is taught to recognize a risk classification, it can use that information to achieve real-time risk assessments. Data collection. The land infrastructures used for the distribution and transmission of data collected by Earth observation spacecraft, deep space probes, and planetary rovers have seen dramatic growth in the volume of data collected over the last decade. The capacity to optimize the vast amounts of data collected by science missions and evaluate them using artificial intelligence automation has a beneficial impact on the way data is handled and distributed to end users. To build maps and data, the spacecraft's artificial intelligence can independently detect and classify normal features, such as common weather patterns, and distinguish them from atypical patterns, such as smoke from volcanic activity. We can use artificial intelligence to identify which datasets to send ground segments to for processing. We may also use artificial intelligence technology to eliminate data that is of little or no use. This can alleviate the difficulties or limitations faced by space-to-ground networks while transmitting huge amounts of data. Assistants and robots enabled by artificial intelligence. Are you familiar with the terms TARS and CASE? Yes, I mean the robots from the well-known movie Interstellar, which, if you haven't seen it yet, I strongly urge you to do so. Imagine how useful TARS and CASE would be in supporting astronauts in real life if you remember their roles in the movie. Scientists are working on AI-based assistants to support astronauts on missions to the Moon, Mars, and beyond. These assistants are designed to anticipate and understand the needs of the crew, as well as understand the emotions and mental health of the astronauts and take appropriate measures in the event of an emergency. So how do they achieve this? Sentiment analysis is the solution. Sentiment analysis, also known as opinion mining or emotion artificial intelligence, is a subfield of natural language processing that aims to recognize and extract opinions from given text through blogs, reviews, social media, forums, news, and other sources. Robots, on the other hand, can be more useful when it comes to physical assistance, such as helping to pilot spacecraft, docking, and dealing with difficult situations that are dangerous to humans. Much of it may seem speculative, but astronauts will benefit greatly from it. Exoplanets discovered by Kepler. The Kepler telescope was built to determine the frequency of Earth-sized planets orbiting Sun-like stars, but these planets were on the verge of being discovered. Even with a low signal-to-noise ratio, determining the occurrence rate of these planets requires an automatic and precise estimation of the probability that individual candidates are indeed planets. To address this limitation, Google and other scientists developed AstroNet K2, a convolutional neural network that can determine whether a signal from the Kepler Space Telescope is a transiting exoplanet or a false positive generated by astrophysical or instrumental phenomena. They discovered two new exoplanets, Kepler 80g and Kepler 90I, orbiting the star systems Kepler 80 and Kepler 90, respectively, after training their neural network model with 98% accuracy. There are a plethora of different research projects involving the application of artificial intelligence to space exploration. Nothing can be guaranteed, as with other AI applications. At the end of the day, everything AI can do requires human intervention. Artificial intelligence is getting closer to providing new insights and is proving to be a boon to humanity in the exploration of interplanetary space with new machines, projects, and research with each new innovation. Especially in the facilities that can be obtained in navigating spacecraft in space and determining orbits with great mathematical precision. Thanks for watching. We hope you found this information educative and helpful. Subscribe for more content about breakthroughs in science.